Hello, Algebra 2 students. If you're working with Bell and you have this Chapter 1 review, I'm going to go through all of these because each question is over a different concept. So pause this video as needed as I'm going to go through it, at a kind of fast pace. But for you to, in order to understand, you may need to pause it and take a deeper look at each one of these. So the first one, what is the simplified form of each expression? All I did was the order of operations here. Remember, these brackets represent just a second set of parentheses. So I work on these parentheses first, and then from there I'm going to work on, thank you, Matt, I'm going to work on what's inside the greater, the more outside parentheses. And let's take a look at it here. So I did what's inside the first parentheses first. I did the exponents. So 5 squared became 25, 4 squared became 16. Then 25 minus 16, 9. And then I did my division. And now I'm working in that outer set of parentheses. 36 divided by 9 first I do. And then I add that. I get 13. I end up getting 13 times 13 is 169. When you're looking at number 2, I'm going to look at the highest exponent values first. So the m squared, I don't have any other exponents. So I'm going to m squared here and m squared here. Since they're both m's and they're both squared, I'm going to put these two together. 2.5 plus 5.3. All these other ones are just n, and n. So pretty much what I did is I just took 7.8 minus 3.2 minus 5.9. Here's what I ended up with. I ended up with 7.8 and m squared minus 1.3 n. That the n's ended up being a negative number. For number 3, I put all my d's together. This is, and I got a d over here too. So you're just combining like terms. So I just took 5 minus 1 minus 2 minus 3. And then this is what I ended up with. I ended up with a negative 1d, or just negative d, plus 8 equals 0. I subtracted 8 from both sides. I was left with negative d equals negative 8. I don't want to know what negative d is. I want to know what d is. So I multiplied both sides by a negative 1, and that gave me positives. Or you could just think of it, whatever you do on one side of the equation, you do on the other. So I took away the negative, I took away the negative. So d equals 8. Number 4. I do the distributive property first, and then I isolate the variable, and you could see that being done over here. I did the distributive property, and I ended up with 14 plus 14z. I took that negative 7 times negative 2 and got positive 14, and same thing over here. I end up dividing 56 by 14. I end up with 4z. For number 5. For number 5, I have the 6x minus 3 equals 5x minus 5. I end up just isolating the variable. And here I end up with x minus 3 equals negative 5. That was from subtracting 5x from both sides. And then I add 3 to both sides, and I get x equals negative 2. For your number 6, what I'm going to do is I'm going to combine like terms. So this 14 minus 7 is going to just give me 7. And over here I have 7x minus 4x. And this is what I end up with in number 6. It looks the same. It's kind of mirrored. 7 plus 3x equals 3x plus 7. Any number you put in there, it's always going to work. It's always going to work. 0, 1, 2, 3, any negative numbers, for the x value. It's always going to work. It's always going to equal each other, so that's an always answer. For number 7, I'm just solving for k, so I end up subtracting 2 from both sides, and I end up getting this. 2k is less than or equal to 6. I divide both sides by 2. This is the graph of this. K could be less than or equal to 3. So I just have 3 on a number line, and I have a solid dot, and then I shaded everything less than 3. It's a solid dot because it could be equal to. Taking a look at your number 8. Number 8, I do the Number 8, I do the distributive first. Okay, and I did the distributive in this step here, and I end up getting this problem. It's hard to see my B's. My B's kind of look like 6s also, but those are B's. I try to make them look like B's. You end up getting this, where 18 is greater than or equal to 0. If it just was greater than, sure, that would work, and any solution, I guess, would work in there. But this is a no solution because no time is 18 ever going to be equal to 0. Just not happening. So I put a no solution on that one. For number 9, now I did something that Mrs. Bell said never to do. I don't know why, because I get the right answers when I do it, and I don't know, I check it on my other calculator and everything. And anyways, I do use the distributive property in here, but if you just were to, and I have another example of a problem that's like this where I don't do the distributive property. So I add 3 to both sides, and that gave me a 9 over here. I ended up doing the distributive property though, and that gave me the 12x plus 9. So I have that equal to 9, and I also have it equal to negative 9, because absolute value, if I get rid of the, negative 9 or 9 would equal 9, obviously. So I end up solving it for when it equals 9, I get x equals 0, and I ended up solving it for negative 9, and I get negative 1.5. And you'd get the same answers if I did not do the distributive property. If I would have, divided both sides by 3 instead of doing the distributive, you get the same answer. So that's number 9. Number 10, looking at some more absolute value problems. What is the sum of the solutions of that? So what I did was, here I don't do the distributive property. I added 5 to both sides, I end up with 4, and then I just divided this 4 by both sides, and then I get it equal to 1. And so I get 3x minus 5 equals 1, and it equals negative 1, because both 1 and negative 1, the absolute value of that equals 1. I end up getting a 2 and a 1 1/4. Okay, taking a look at number 11. Solve the inequality and graph solutions. Here I'm going to go ahead and, I used the distributive property again on this one, and I got the same answer. If I wasn't, I get x is going to be less than 4.16, and that's a repeater, and x also is going to be greater than 4.83, and you can see my process there. I have it graphed here too. You may need to pause that in order to see that. The open circles, because they are not equal to, they're just less than or greater than. For number 12, I go ahead and get rid of the absolute value bars, as you can see here for number 12. And then I solve for it equaling positive 22, and I solve for it equaling negative 22, and I flip the sign when I do that. And this is an OR. You can see my process there, and then you could see what the graph would look like. It's greater than or less than or equal to negative 13, and greater than or equal to 9. Okay, and then 13, I have 13 here, and you could see my process here. I set it less than or equal to 15, or greater than or equal to negative 15. I get those two different answers. This is an and. You'll see it's in between. Whenever it's in between the two numbers, it's going to be and. Solid dots because it could equal them. All right. For number 14, what I did was I had to add 4 to this part, and this part in order to get rid of the 4. And I did that, and I end up with this. Then I divided all 3 parts by 2 in order to isolate the x. Ends up looking like this, and that is the graph of it right there. Open and closed. And you know why. 15. We got this one or this one, so I had to solve both of those, isolating the variable, and you could see my process here. I did the first step here, and then I did the last step. And then the graph of it is going to look like that. Okay. Number 16, I have it written there. It's a never, but the problem looks like this. And it's never, because once you start working it out, it ends up being 11 times x minus 10 is less than or equal to 11x plus 13. Let me tell you, because when I subtract 11x from both sides, I get negative 10 is less than or equal to 13. Once again, if it was just less than, that would be good. But it's less than or equal to. Is negative 10 equal to 13? No, never will it be. 17. I work out this problem and this problem. And I do my first step as I write it down, and then the last step, and then you have the graph. It's going to be in between, it's an and. 18. I do the first step, which is add 5 to both sides on this one and subtract 13 from both sides on that one. And you can see I've done that. And then I go ahead and do the last step, divide by 9 over here, divide by 3 over here, and I get that as my graph, open circles. Okay. And lastly, I'm going to add 4, add 4, add 4, add 4, and then divide by 2. So I added 4 here, and now I divide by 2, and that puts my x in between negative 3 and 5. Could equal negative 3, so it's solid there. So hopefully this helps you get prepared for that test.